Hello there. Uh, Welcome to lecture 5. Till lecture 4 we typically looked at several functions and aspects of communication between functions, etc. Let us now look at the visibility of a function across files. So what does that actually mean? For example, suppose if I have a function called int f1, okay, and I have defined a prototype, and I refer to just refer to f1. So when I do this and try and compile this program, so I need to give hash include, okay, and now I have this program wherein I will be compiling this. Now if you look at f1, I have not given any parameter, so let me just give 12 from here. I don't know where the function is declared, but the prototype is declared now. It's exactly like our, okay. So when I do this, we have undefined reference to f1, means f1 is yet to be defined. So for that, what I will do is I will just ask the compiler to compile the program. So what do I do for that? I just do the -c. So when I do the -c option, if I now do dir of 1 dot star, I have a .o file. Okay, I have just compiled and assemble but not linked. So let me declare one more file. I will call it as, this is my 2 file 2. So here I will define probably f1 int x. I will print a statement. This is f1 from file 2, from file 2, okay, and then I'll display the value received, whoever is calling, from the caller is %d, say let me call it as x. So this does not contain a main. If you see, I will save this as 2.c, okay, .c. I have saved it at 2.c. This also I will compile now. I'll just compile gcc -c 2.c. Okay, what is that errors we have here? Okay, so I did not give a semicolon. Let me save this and do the recompilation. Warning, that's fine. I'll also include a file because this is a new independent file which contains, so I can have multiple inclusions. We will see how to avoid all of that later. So I have now 2 files which are object files, which I'll now link together to create, okay, an exe file using external linkages. Let me see what will happen here. I'll see gcc -o output to 1.o, 2.o. Okay, 1.o, 2.o. So now it has built the file. So let me give the output now. if I look at the output, if you see, it is now able to recognize this is F1 from file 2. The value that I received was 12. So if you see, the beauty of this is my function is in file 1. From file 1 I am calling a function that is there in file 2. Okay, this is the meaning of what is called an external linkage. For example, suppose if I say let me go to, now I have a file, I will declare here int z, for example. Now when I declare int z and pass z here, okay, now my z here may be 1000. Okay, so I will again do the same thing. Now I have to compile separately, or I could as well say gcc minus c 1.c comma 2.c, so I can together do that. Okay, 1.c, so it has generated. So now I will also create minus o of that and look at the output. Okay, look at the output. So if you now look at this, it is now, the problem with this is I have, oh I'm sorry, this is bad syntax, so that's why it is giving the other value. Okay, so I have declared it as z. So let me again recompile this and relink this and do the output. Okay, so now it is able to take from file 1 1000. Okay, now suppose if I go to my file 2, if I go to my file 2, which is an independent file altogether, like I'll go to my file 2, and in 2 I would like to now refer to z of file 1, refer to z of file, referring to z of file 1 is %d. We'll see if it is able to give 1000. It is able to give 1000 because I pass z to this x, right? But now I am trying to directly access z. Okay, so do that. Let me just try and compile both of them. If you look at this, it says z undeclared, which is true because it doesn't know what z is. So here I will say extern int z, means I am telling the compiler that this variable z is declared here but defined elsewhere. So I'll ask the linkage editor to find out that. Okay, external linkage or linkage editor to find out that. So I am not worried about it. So let me see if it is able to find out. Okay, it says 1.c. I say output. So now it is able to receive the value. Did I save this? First of all, save this. Let me recompile this. It is not giving us the changed one. So I will do the minus gcc, then I'll have to do o. I think I forgot to do the o. Then I get the output. Yeah, now it's referring to z, because I said externate. So this is called as an external linkage. So I know I am able to do it across. Now I may be having a problem with this. For example, if I remove extern here and say let me make this as float of z, and I'll say 12.3 f, and I will referring, I'll just say now in this case z is, let me see what it will do. Z is, I know in this case it is %f. I'll just display z. Let me see what will happen here, right? So let me compile this now. First, to start with, I have compiled it, no issues. Let me try to link it and see what will happen. Okay, Now if you see, it is now taking z as multiple definitions of z, because when I independently compiled file 1 and file 2, file 1 knew about its z and file 2 knew about the its z. In file 1 the z was int, in file 2 the z was float. But when I gave it to the external linkage suddenly saw that there are two z's, so it looks at multiple definition. So how do I keep this z to this file and that z to the other file? Okay, let me just try and do something like this. Now suppose if I say static z, I don't know about this, let us just try. If I do something called static z, will it restrict itself to this? Okay, so let me compile this first, no problem. Let me link this next, no problem. Okay, now it is able to recognize my 12.3 and this z is this z, correct? Now if I want to access the value of that z there, which means suddenly what may happen, you may think, okay, let me make extern int z. So maybe because it is static, it is able to differentiate, and this z it may take it from there, right? Okay, so for that, but when I want to display z, there will be an issue. So straight away we could see there may be some error there. Okay, so what we will do is we will compile this. See, it is again z and z, so we are saying z is static as well external, it is not possible. But if I still want to access the value of z there, so what I have to do for that is I have to go to that file name, which is my 1.c file name. Here I have set z equal to a, I mean int z equal to 1000. Suppose if I try to make, for example, you may say, sir, make a as z, a equal to z, and then try to compile this. So if I try to compile this, it says element is not a constant, so I have a problem. So what I'll do then is I would probably say int and of int star of a equal to and of z. Now if I do something like this, and then I will go, this is my file, so let me compile this file now. Okay, now it is going to multiple declaration conflict type. I'll go to file 2. So let me go to file 2. So when I go to file 2 here, this is my file 2. In file 2, now I will say extern int star a. Okay, this is my extern int star a. Now I will dereference that star a and still get the value of z. So what would I do? I will say z is nothing but external z is nothing but what? Star a. Okay, which is, let me see, percentage d. I'll dereference star a. Okay, now let me save this file and try to compile both. Okay, so now looks like we have no problem with this. So let me do the output. Now it is able to recognize my z. See, 1000 in the form of so can we have something like this? For example, suppose now if I have a file in, let me copy this file, for example, let me copy this file. Okay, and I'll have the same file, the same name in 1. I'll have the same file in file name called 1. Now when I do this, for example, and I copy this here, okay, so I have a file, this is my main from file 1. Okay, so this is my file. First let us see, can we have something like this? So I have two file names with the same file name. Now I am calling f1. Let me see what it will do. So let me save this and try and compile this, and let me do the output of this. Now if you see, it again takes f1 as multiple definitions like your variable. So for that, what I could do is I could probably go to file2 again, okay, or maybe make this a static, so it will remain to this file. So if I probably do that, let us see whether that will work. So here I do gcc minus c previous, okay, so because I have defined it, let me say it as static. Alright, so if I want to do execute now and get the output, I have no problem with this. It is now able to recognize this. Okay, now because now this is restricted to file. So suppose if I now want to access that file with the same name f1, then we will have issues. For that, what I will do, I will go to file f2, probably I will go to this 2. I have now f1 here, so probably what I could do is I could maybe define a pointer to a function. Okay, so this will be my star say fp, which is my function pointer, with int. This will be equal to my end of say f1. Okay, let us see what will happen. So I have created an fp. So let me first separately compile -c2.c if there are any errors. It says external use. Okay, so I think these things are error. So let me just take this out, so to just avoid errors. So let me just compile file 2. It says unique name, yeah, because I have to just give the name. I am done a function call, so I'll remove these two brackets. When I remove these two brackets, so let me just again separately compile this and see if I can remove that error. Okay, I did not save this, so let me save this code and then recompile this. It says undeclared f1, not a function here. Oh, that is because I have to define the prototype. So let me just define the prototype, int f1 int. Okay, so I have saved it. Let me see if we are successful in eliminating this error. Yeah, fine. So we are successful in eliminating this error. Now let me go back to my 1. Let me go back to my file number 1 and see if I am able to do access this file. So maybe I'll say extern int star f1, which was int. Okay, I think this is what should be the syntax. And now if I call, for example, my, oh, this is not f1, this is fp, right? That's my external. Suppose if I have call star fp with say 100, that's my syntax. Let me see, I have to compile this separately first. So I will compile 1.c, no problem. So I will take both of them together. Oh, no problem. And then I'll try to do the output. I have already got the file, isn't it? So this file has the same name, correct, as that file, but I could get I could point a function pointer to that file and still call it here. So which clearly now means that external linkages are possible. I can be modular within a file. I can be modular across the files, and at the same time make the functions or variables visible to all the modules which finally. So if you have any doubts, you could please contact me at nitinpujari@gmail.com. I request all of you to go through this video till you understand the concept. Thank you.